Hi there, my name's Tom Ralfs and I'm here to discuss my final year project for my Bachelor of Engineering degree. So my choice was to measure the water velocity in a water channel that we have at the Fluid Labs at university, and my design was to be able to measure the water velocity through the channel at any point with various obstacles in the way, so we can measure before and after it. Now the original that came with the water channel was particularly fiddly to use and only allowed the measurement to be able to be done along the length and also the depth, but not across the width, which was one of the constraints that was needed in my design, which was pretty good. Now the actual measuring is done by a pitot tube, which is located in the water in front or after an obstacle, to be able to measure the difference perhaps in water velocity before or after the obstacle. Now the one that came with it was just a clear plastic tube, and the water level would rise up and down depending on the water velocity, which was pretty basic. You had to input the measurement into a formula to then work out the water velocity, which is fine for individual, simple, basic scientific experiments, but if you want to do multiple readings in a short space of time, then it doesn't help you very much. Now my solution fixed the problem because it involved a modern electronic pitot tube which could be plugged into a data logger or a computer or both, and data could be logged at periodic times for as long as you want, effectively, and at a much more accurate way than a analog version, which is all to do with how well you're measuring it in the first place, so it eliminates that potential for failure there. Now I had to make it so it was able to be installed and mounted onto the uni's own water channel with no special tools, to keep costs down and to allow an engineering student or a boat student to be able to fit it easily with no worries. Now my design used a elevated monorail type thing. I've got some photos of it here, except at the moment I've had to, in absence of the actual thing, so I've got a rail there which allowed a carriage to slide along. Now on this carriage, I don't know if you can see it there, but there is a retort rod, and mine worked had an arrangement of retort rods. The pitot tube would hang off that, and more of the carriage there, and then be mounted in position, fixed by a couple of clamps with a butterfly type adjuster on, which then clamps the bar to a clamp in a V-type clamp thing. Worked very well, held it in place, could handle easily the load that 10 metres of water per second would be pushing on the end of the pitot tube. Now it was mounted quite rigidly. A couple of G-clamps would be on the bottom of the water flume, which allowed it to be removed and put on without any issues. Now, interesting part is that the most interesting part was the fact that simple tools could be used. Retort rods were easily available, very cheap online, and were a good solution for a project such as this. Very easy to use and no training needed. Now, the most difficult thing was deciding on a way to hold the pitot tube in position. It needs to be easy to use and not expensive, and this meant a simple solution was needed. So commonly found science lab equipment was a wise choice, I thought. So yeah, there we go. That was the most interesting thing, using simple equipment, and was also the most difficult thing at the same time. Thank you very much.